Hi everyone, welcome back. In this video, we're going to talk a little bit about slope and what slope means and how to find slope for lines and linear functions in Algebra 1A. Okay, so slope, one way to think of slope is the steepness of a line. So how steep is the line going up versus is it kind of flat or is it even going down? So the steepness of a line is one way to think about slope. Another way to say that is to ask the question, how do y values, how do the y values change as we increase the x values? In other words, as we go to the right, if we're looking at a graph. So how do the y values change up and down as we go to the right, as we move to the right along the graph? Okay, one way to define slope is as rise over run. So you might hear rise over run, where rise means the up or down change, the vertical change, and then run means the horizontal or left or right change. So x value change. And another way to write this, which you might have seen in some Desmos activities, is we have a triangle y divided by triangle x. So this triangle is actually a Greek letter delta, and it stands for change in. You'll see this in other classes like physics, other science classes. Triangle or delta means change in, so the change in y divided by the change in x. So how much do our y values change as our x values? Okay, so let's take a look at a few of the lines listed on the left there. So first, looking at the blue line. As you can see, we start at 0, 0 for all of these. And what we could do for all of these is look as we go to the right, how much does our vertical line, how much do our vertical values change? So if we start at 0, 0, we end up going up 3, and then to the right 1. So for this blue line, our slope is going to be the change in y, which is 3, divided by the change in x, which is 1. So 3 over 1, which is just 3. So we have a slope of 3. And this continues as no matter what points we choose on the line, the slope will be the same. Here we go, up 3 to the right 1. Another thing we could do is we could choose points that are farther apart, and we'll end up with the same slope. So another way to look at this is we can choose to go up 6. So here we went up 6, to the right 2. So we went from 0, 0 to this point over here, 2, 6. We have a vertical change of 6, a horizontal change of 2, which gives us the same value for the slope, 3. So any 2 points that we choose on our graph, we could look at the change in y divided by the change of x, and then use that to find the slope. For the red line here, you can see we go to the right 1, up 1, right 1, up 1. So for red, our slope is going to just be positive 1. For the orange line, this one's a little bit different because here we're going down 1. So down 1, and then to the right 2. Down 1, right 2. So when we talk about slope, we're looking at the sign that we use. Positive or negative is important. If our graph is going down, then we have a negative slope. So here our slope is going to be negative 1 divided by 2. So our down 1, change in y, divided by the change in x, which is 2. We have a change in x of 2 between these 2 points, 0, 0, and 2, negative 1. So negative 1/2 is our slope for orange. If we have a positive slope, that just means that our line is going up. So our line is going to look like this. Negative slope, our line is going to be going down. And we can see that with blue and red. Those are both positive, so they're going up. Whereas with orange, it's going down. As you can see, a measure of steepness 3 is greater than 1. So that's why our blue line is steeper than our red line. More vertical in a way. Okay. So we can take points on a graph and use those to find slope by looking at the change in y divided by the change in x. And sorry, I realized now that I was blocking some of this. So as you can see, we go down 1 to the right 2. So our slope is negative 1 divided by 2, or negative 1/2. All right, so next up I want to talk about two special cases. What happens when we have a slope of 0 and a slope that's undefined? So a slope of 0 just means as we go from one point to the next on the graph, we're going to go up 0. So our vertical values are not going to change. And then to the right, for example, to the right 1. So up 0 to the right 1. So if we start at 0, 2, our next point is 1, 2. Up 0 to the right 1, up 0 to the right 1. So for all of these, we're looking at a horizontal line. So a slope of 0 describes a horizontal line because our y values, our vertical values, aren't changing, aren't going up or down. We could also have a slope that's undefined. And we see that if we have a line that's vertical. Because here what happens is we start at this point, for example, we go up 1 and then to the right 0. So we don't have a horizontal or x value change. So when calculating slope, we would write change in y over change in x, which is 1 over 0. And then we're dividing by 0. So that's how we get an undefined slope. So with vertical lines, we have undefined slopes. For horizontal lines, we have a slope of 0. All right, finally, one more point I want to go over is finding the slope from two given points. So on this graph, I've listed 2 points, 1, negative 4, and 3, 2. And we can find the slope using our change in y divided by change in x ratio or fraction. So here, generally, let's say we're given 2 points. We'll call the first point x1, y1. So the x value of our first point is x1, the y value of our first point is y1, and I'm just putting a 1 down into the right as a subscript to indicate that this is the x and y value corresponding to our first point. x2 and y2 are the x and y values corresponding to another point. And we can write change in y over change in x by taking one of the y values, for example y2, and subtracting the other y value. So we could do y2 minus y1. Then in the denominator, we have to take the x value corresponding with the first y value we listed, so x2, and then subtract x1. It doesn't matter if you have the 2 or the 1s first, as long as they line up. So we need to make sure that the 2s are lined up and the 1s are lined up, either on the left side or the right side. So for example, here, our second point we could call 3, 2. Our first point, 1, negative 4. y2 is 2 minus y1 is negative 4. So here it's important we use parentheses when we plug in negative 4. x2 is 3. And x1 is 1. So 2 minus negative 4 is 2 plus 4, or 6. And then 3 minus 1 is 2. So 6 over 2 is 3. So given 2 points, we can find the slope using our slope, this equation right here, using the x and y values of the 2 points. You might also notice here we go up 6 to the right 2. So up 6 over 2, 6 divided by 2 is 3. Okay, so here we looked at finding the slope of lines on a graph, and then also finding the slope of a line given 2 points on the line.